Can an ultra-smart AI predict exactly what would happen if Earth suddenly stopped spinning right this moment? It sounds like a science fiction plot, but imagine for a second that a supercomputer has all the data. Would we even want to hear the terrifying results? Welcome to Explain Like I'm 5, where we take mind-bending topics and break them down into fun, easy-to-understand stories. Ready to get curious? Let's dive in. Earth spins on its axis once every 24 hours, giving us day and night. It's like a giant spinning top that's been rotating for billions of years. You probably don't feel it, but at the equator, you're moving at about 1,000 miles per hour relative to Earth's axis. That speed is spread out over the entire globe, yet we hardly notice it. If you've ever spun a bike wheel and felt it wobble when you suddenly try to stop it, you've experienced a tiny piece of the enormous force involved. Why is Earth's spin so important? It helps distribute heat from the sun, gives us our day and night cycle, drives weather patterns, and supports life as we know it. Imagine if you flipped a switch and Earth's rotation halted instantly. Everything not firmly attached to the ground would keep moving at up to 1,000 miles per hour, zooming eastward. If you've ever been in a car that slammed on the brakes, you know that objects keep moving forward. That's called inertia, and on a planetary scale, it would be catastrophic. Oceans would be especially dangerous. The water currently rotates along with Earth, so stopping the planet would make the water slosh everywhere. Giant waves like titanic tsunamis would wash inland, flooding entire cities, farms, and forests. Everything near the coast would be in serious danger. It's hard to imagine the force of millions of cubic miles of water all rushing at once, but it would make any earthquake tsunami seem tiny in comparison. Our atmosphere would also keep moving, whipping the air into colossal windstorms. Those high-speed winds could tear through buildings, trees, and just about anything in their path. This alone would be an enormous global disaster. Meanwhile, people would be hurled eastward, along with cars, animals, and loose debris. Cities and roads would be turned into chaotic messes of concrete and metal. Beyond the immediate smash-up, there's also the matter of day and night. Earth's rotation is what makes the sun rise in the east and set in the west every 24 hours. If the world suddenly stopped, one half would face the sun constantly, becoming extremely hot. The other half would remain in permanent darkness, growing freezing cold. Life on both sides would struggle. Plants, animals, and humans rely on the regular cycle of light and darkness to sleep, grow, hunt, and stay healthy. Crops might not survive without the usual pattern of day and night. Animals could become disoriented or even die off. Humans would find it almost impossible to farm in endless sunlight or complete darkness unless we developed entirely new technologies. We'd be forced to find the narrow twilight zone between the scorching daylight side and the frozen night side, possibly the only habitable region left. Then there's Earth's magnetic field, generated partly by molten iron in our rotating core. This magnetic field acts like a protective shield against harmful solar radiation. If Earth's spin stopped, that swirling metal deep beneath our feet could also slow or change over time, potentially weakening this magnetic barrier. We could face more radiation from the sun, harming people, animals, and our technology. Although it wouldn't vanish instantly, the long-term effect would be severe. AI researchers love imagining these colossal scenarios because they can feed data about oceans, atmosphere, continents, and more into huge computer models. The AI could estimate the tsunami heights, wind speeds, and destruction patterns. We might learn which areas would be hit first and how fast the water would travel. In theory, that could help with disaster preparation, but in a sudden planetary stop, the devastation would be so global that no technology we have could manage the chaos. Even if we had bunkers, we might still face floods, fires, and storms on a scale too big to handle. But how realistic is this scenario? Earth is massive, about 8,000 miles across, and there's no known force that could just yank it to a stop right away. There are minor forces like the gravitational pull of the moon that slowly affect our rotation, making days fractionally longer over millions of years. That's why, in real life, Earth's rotation will keep changing at a barely noticeable pace. However, it's still an interesting thought experiment. It shows us the delicate balance we live in. We take Earth's spin for granted, but it's a big part of why life works the way it does. We also learn a lot about inertia and momentum from this scenario. Inertia explains why you fly forward if a car stops suddenly. Momentum explains how everything keeps moving in the same direction until acted upon by another force. On a spinning Earth, these forces are spread out smoothly, so we rarely notice them. A sudden stop would unleash that momentum violently, with terrifying results. Thinking about Earth without its spin also helps us appreciate day and night, which guide our daily routines. Our bodies follow circadian rhythms, telling us when to sleep, eat, and be active. A world in perpetual daylight or nighttime wouldn't just be depressing, it could disrupt ecosystems everywhere. Plants need light to grow, but also darkness for certain processes. Animals have evolved around sunrise and sunset patterns. Humans have built entire civilizations around the 24-hour cycle, from how we schedule work and school to how we generate electricity and track global time zones. In a future without spin, it's possible some part of humanity could survive by clustering in the mild twilight zone, building high-tech cities that can regulate temperature, possibly recycling water and air. Perhaps AI would help us figure out the best farming methods for such an environment. But it would be a drastic, uncomfortable existence compared to the life we enjoy now. Our global transportation systems would be shattered, the oceans might settle eventually, but the new coastlines would look nothing like they do today. The planet's weather patterns would be bizarre, with winds possibly blowing from hot to cold regions constantly, and the permanent darkness side might become icy, creating huge glaciers that never see sunlight. While this scenario is horrifying, it's a good reminder of just how special and fragile our living conditions are. We rely on a steady, rotating planet, a protective magnetic field, and a balanced cycle of day and night. If any part of this system changes too quickly, life has a hard time adapting. That's why scientists keep studying Earth's rotation, climate, and magnetic field. Even subtle changes can cause big effects over time. AI can help us predict how these changes might play out, giving us a chance to prepare, adapt, or at least understand the possibilities. As for the fear factor, it's okay to feel a bit uneasy when you think about the enormous forces that keep Earth stable, but don't worry, there's no giant cosmic hand waiting to stop Earth's spin anytime soon. Our planet's daily rotation is part of its identity, like the spinning of a top that just keeps going. The scary part isn't likely to happen. Instead, we can look at this as a learning experience, a way to see inertia, motion, and planetary dynamics in action. So the next time you watch the sunrise or sunset, or notice how day turns into night, remember this: you're living on a spinning spaceship, hurtling through space at amazing speeds. The fact that it all feels normal is a testament to the balance of physics and nature. When you think about it, it's pretty incredible that we can stand here, spin along with Earth, and not even feel dizzy. That's how powerful and smooth our planet's motion is. Imagining it stopping might be terrifying, but it also reminds us just how lucky we are to have a home that spins so perfectly. Thanks for watching. Don't forget to like, subscribe, and drop your questions in the comments. See you next time on Explain Like I'm 5.